So as a starting point, let us consider a triangle ABC with vertices A, B, and C. And in red, you can see the height of the triangle. Now, the side opposite to the vertex A will say measures little a. The sides opposite to vertex C will say has a measurement of little c unit, and the side opposite to vertex B has a measurement or length of B unit. And we will say that the height measures exactly AX. So in other words, what we are saying is that AX is H, AC is B, BC is A, and AB is little c. Now we let K sub A, B, C be the area of a triangle ABC. And we know, I'm pretty sure everybody knows at this point, that the area of the triangle ABC is base time height over 2. So in this instance, we can say it will be A, little a, time H over 2. Okay? Now let us consider this triangle here. The triangle AXC. As you can see, by construction, the triangle AXC is right at X. So we know that sine of angle C will then be, so the sine of this angle will be opposite over hypotenuse, so it will be H over B. And solving for H, we should get that H is B sine of C. So remember that the area of our triangle, we saw that it was AH over 2. So after substitution, then if you substitute H for B sine of C here, then we get A times B sine of angle C over 2. Now let me turn my attention to this triangle. Yeah. So again, this triangle, the triangle AXB, is right at vertex X. Now let's consider the angle B. If we compute sine of angle B, that will be again opposite over hypotenuse, so that will be H over C, and solving for H, we get that H is equal to little c times sine of B. One should not be confused about my notation when I'm switching from vertex to angle, right? So it's a little bit ambiguous, because so sometimes I use ABC to denote the vertices of my triangle, and sometimes I use the same variable to denote the angle. So it should be read from the context. In any case, the area of the triangle ABC, which is again AH over 2, now will be AC sine of B over 2. And again, this is simply due to substitution, by making the substitution highlighted on the screen. Next, I will consider another height for the triangle. The height that I'm considering here is precisely this one here. Okay, and I call it. I would say that's maybe let me put some. So let's put y here, and I will say that h prime is equal to by, and the area of the triangle ABC does not change. It's still base times height over 2, but we have a different base now and we have a different height. So it will be by times AC over 2, which will then be h prime times b over 2. Okay, and now I will focus. Perhaps let me use a different color. I'll focus on this triangle here. So notice that triangle ABY is right at y. Okay, and then sine of angle A, so this angle here, is going to be opposite, which is h prime over hypotenuse C, right? So then thus the area A of the triangle ABC becomes now, if we solve for h prime, we get C B sine of A over 2. So to summarize, so far we have proved that AB sine of C over 2 is equal to AC sine of B over 2, which is equal to BC sine of A over 2. Now, and all of this are all equal to the area of the triangle ABC. So we'll multiply our equation by 2. So after multiplication by 2, we get that AB sine of angle C is equal to AC sine of angle B, which is equal to BC times sine of angle A. And then we will divide by ABC. So if we divide all of this by ABC, then we get sine of C over little c is equal to sine of big B over little b equal to sine of A over little a. Right? So you divide and then you simplify. Now taking the inverse, gives that C over sine of C is equal to B over sine of big B, which is equal to A over sine of big A. These remarkable formulas actually has a name. It's known as this formula is known as the law of sines. Our next result states the following. Let AX be the bisector of angle A in triangle ABC. Then BX over XC is equal to AB over AC. In other words, what this means is that the point X divides the segment line BC into pieces which are proportional to the length of the nearest side of the triangle. So again, to be a little bit more explicit here, I'm going to introduce more notation. So this angle here, let's call it alpha, and this must also be alpha because AX is a bisector. And I will say that U is the measurement of BX, and little v is the measurement of XC, and the side opposite to vertex C, I'll call it little c, the side opposite to vertex B, little b, and this here is of course little a. So if you were to prove this result, we will have to show, so we really want to show that U over V is equal to C over B. In other words, green over blue is equal to the other green over the other blue. Okay, H be the height of triangle ABC with respect to base BC. Then the area of triangle ABX, we know, so this triangle here, we know that will be U time height H over 2. Now let me label AX, let me call the measurement of this X, and this will be a height, and we know that the area of ABX will also be base times height over 2, right? Now our new base is C. So what we'll have here is C time our new height is going to be the hypotenuse, which is X time sine of alpha over 2. Okay. Similarly, the area of a triangle ACX is going to be VH over 2. Okay. All right. Now, let me choose this height for our triangle. And if I were to rewrite again the area of our triangle, it will be base times height over 2. The new base here is little b. The height is, which is here, I'm going to put it in blue so you can see it, will be sine of alpha times x. Okay, so x times sine of alpha, and again this is over 2. Now let us rewrite maybe everything in a way which is a little bit more transparent. We now have u, which is bx times h over 2 is equal to c, which is ab, times x, which is ax, times sine of alpha over 2, and v is xc times h over 2 is equal to b, which is ac, times ax sine of alpha over 2. Now I'm going to call this here star, and I'll call this one here double star. And the point is, now we know that bx over ab is going to be equal to ax sine of alpha over h, and using this here we get cx over ac is equal to ax sine of alpha over h. So these two quantities are equal to each other, so we can then say that bx over ab is equal to cx over ac, and this is in fact equivalent to bx over cx equal to ab over ac, which is exactly what we want. In this problem, suppose that in triangle ABC, the median from vertex A and the bisector are on the same line. Then we would like to show that AB, the measurement of the segment line AB, must coincide with the measurement of the segment line AC. So let's label things here. Suppose this measure U, this measure V, C, B, and then A. In other words, U is equal to BX, V is equal to XC, little a is BC, little c is AB, and little b is AC. Now, by assumption, we know that little u is equal to little v. Why? Well, because ax is a median. All right. So u over v is going to be equal to c over b from the previous results that we've shown, right? So the ax, the point x here is dividing side BC into lengths which are proportional to the nearer sides of u and v respectively. So u over v is going to be equal to c over b. And because u is equal to v, so this will be essentially u over u, which is going to be equal to 1. Thus, c must be equal to b, and we conclude that AB must be equal to AC, because little c is AB and little b is AC.